Hello students, I am ready with my next video, and our next video is on the same topic, same subject, mathematics, and the topic is circles. We have already seen two theorems. Two theorems have been completed and one exercise has already been completed. Now we are moving towards the next exercise, but before the exercise there are some examples in the reader. We are following NCERT curriculum, NCERT syllabus for class 10. And now the question is, the example is after the theorem 4.2 in my previous video I explained. Now example based on the two theorems which we studied, 4.1 and 4.2. And the example says, prove that in two concentric circles, there are two concentric circles. Concentric circles, two circles having same center. If you observe carefully, this circle, bigger circle, has this radius. Imagine has this center O, and this smaller circle also has radius O. So two or more circles having same radius are called concentric circles. So there are two concentric circles. The chord of the larger circle which touches the smaller circle, larger circle has a chord. Suppose the name of the chord is AB. AB is a chord. Chord is a line which touches 2 points, which joins 2 points on the circle. So point A and point B are 2 points on the circle and AB is joining them. Larger circle. So AB is chord of larger circle, but AB is passing in such a way that it is touching the smaller circle at P. So we can say that AB is tangent to smaller circle. AB is a chord of larger circle and AB is a tangent to smaller circle. Now what we have to prove that is bisected. This chord, AB chord, which touches the circle in smaller circle at one point, is bisected at the point of contact. At the point of contact, P is the point of contact. P is the point of contact. At P, AB is getting bisected. Bisect means cut into two halves. Cut into two equal parts. Two halves. So we have to prove that. What we have to prove? That AB is bisected at the point of contact, means AP and BP are equal. This we have to prove. AP and BP are two equal halves of AB. This we have to prove. So we have to prove that AP is equal to BP. It means if we get this, we can say that AB is bisected at the point of contact P. P is the point of contact. Okay. For that, we do one construction. We join OP. I join OP. OP is radius. And we all know from theorem 4.1 that angle between tangent and radius at point of contact is always 90 degrees. We have 90 degree here. We have 90 degree here, right? Radius and tangent are perpendicular to each other at the point of contact, theorem 4.1, right? From theorem 4.1, we are doing this, join OP. Then what will happen? OP will be definitely perpendicular to AB because of theorem. Where did we get this from? 4.1. From theorem 4.1 we understand that OP is perpendicular to AB. Okay. Now join OA and OB also. Join OA and OB. I join OA and OB. I join OA and OB. So join OA and OB also. Right? Now, after joining, OPA is a right triangle. OPB is also a right triangle. If these two are right triangles, then we can apply Pythagoras theorem in them, right? So in this theorem, in this triangle, in triangle OAP, OA square will be equal to OP square plus AP square from Pythagoras theorem. Right? OA square is equal to OP square plus AP square. OP square plus OA is hypotenuse. Square of the hypotenuse is equal to sum of the square of other two sides. OP plus AP. We got this, right? Imagine this is equation number 1. This is equation number 1. Right. Now we can apply Pythagoras theorem in this triangle also. We can apply here in triangle OPB. OB square will be equal to, OB is the hypotenuse. OB square will be equal to OP square plus BP square. Right? Again by Pythagoras theorem. We are applying Pythagoras theorem. This is equation number 2. Imagine this is equation number 2. Yes. Now do one thing. Don't take this as equation number 2. Next. Can I say OA is equal to OB? Can I say OA is equal to OB? Yes, because OA and OB are the radii of the same circle. OA is radius to the larger circle and OB is also a radius of the larger circle. OA is equal to OB, right? So we can say, can I replace this OB by OA? Yes. OA square, I am replacing this OB by OA because OB and OA are equal to this thing I am writing as it is. In this equation, I replaced OB by OA because I know that OB and OA are equal, because OB is equal to OA, radii of the same circle, right? So I can replace. This is equation number 2. Now look at equation number 1 and 2. Equation 1 and 2, LHS are equal. If LHS are equal, we can equate RHS. LHS are equal. OA square is equal to OA square. LHS are equal. So we can equate RHS from 1 and 2. OP square plus AP square. RHS of this equation will be equal to RHS of this equation. What is the RHS of this equation? OP square plus BP square. Right? Now, we have OP square here, OP square here. Can we cancel? Yes, of course, because if I transfer this OP here, it will become negative. Let's say OP square plus AP square. Take this OP square here, plus will become minus OP square will be equal to BP square, right? This positive OP square, negative OP square will get cancelled. I am doing this, you can cancel here also. That will be one, you can save one step sometime, right? Now here we get AP square is equal to BP square. AP square is equal to BP square. We got this. AP square is equal to, the last step is AP square is equal to BP square, right? Take square root on both sides. Taking square root on both sides, what will happen? Square and root will get cancelled. So what will happen? AP is equal to BP, which we had to prove. AP is equal to, if AP is equal to BP means these two are equal, that means P is the midpoint. If P is the midpoint, then AB is bisected, getting cut into two equal halves at P. This is proved. I hope you understood the question. Let's go to the next question. Let's move on to next question. And the next question is example number 2. Two tangents TP and TQ. Two tangents TP is one tangent and TQ is another tangent. TP is one tangent, TP is one tangent and TQ is another tangent. Two tangents are drawn to a circle with center O from an external point T, and those two tangents TP and TQ are drawn to circle with center O from an external point T. Prove that. We have to prove angle PTQ, this angle PTQ is equal to 2 times twice angle OPQ. OPQ is an angle, right? Angle OPQ. This is what we have to prove. We have to get this. Okay, for that, do one thing. Imagine angle PTQ is theta. Suppose angle PTQ is equal to theta. Suppose angle PTQ is equal to theta. I have taken PTQ as theta. I don't want to write PTQ again and again. So every time I need to write angle PTQ, I will write theta, just theta. That will be enough, right? Okay. Now, if you observe carefully, PTQ is a triangle and PTQ is an isosceles triangle. Angle PTQ is an isosceles. Now, reason why it is an isosceles triangle, that I will tell you. We know that angles drawn from an external point to a circle, two tangents can be drawn, and the two tangents drawn from an external point to a circle are equal. This is theorem 4.2. We studied in theorem 4.2 that if we take an external point, if we take a point outside the circle and draw tangents, two tangents can be drawn, and those two tangents will be equal in length. We have studied this in theorem 4.2, our last theorem, right? Now, if TP is equal to TQ, then this triangle TPQ, two sides are equal. If two sides are equal, then it becomes an isosceles triangle. In an isosceles triangle, two sides are equal, and the angle formed by those two sides on the third side will also be equal. So these two angles will also be equal. TPQ will be equal to TQP. Angle TPQ will be equal to angle TQP. Now here I can say that triangle PTQ is an isosceles triangle. Because TP is equal to TQ. TP is equal to TQ. Because theorem 4.2. 4.2 says tangents drawn from an external point are equal in length. So TP is equal to TQ. Therefore, TPQ or PTQ, this triangle becomes an isosceles. If this is an isosceles triangle, then angle TPQ must be equal to angle TQP, because isosceles triangle. In an isosceles triangle, two sides are equal. Also, two angles formed by those two sides on the third side are equal. This is the property of isosceles triangle, right? Now, so two sides are equal and two angles are also equal. So these two angles are equal. This angle TPQ and TQP, this angle are equal. Okay. Now because this is a triangle, PTQ is a triangle, therefore angle PTQ plus angle TQP plus angle TQP, TPQ and TQP must be equal to 180 degree. This angle plus this angle plus this angle. Sum of all angles of a triangle is always 180 degree. So this angle plus this plus this. These three sum is equal to 180 degree, right? Now, PTQ. This we have already taken theta plus. These two are equal. So see, TPQ is equal to TQP, angles of an isosceles triangle. So I write this TPQ plus this TQP also can be replaced TPQ. Why? Because TQP and TPQ, they are equal. So I am replacing this with this because they are equal. I can replace this is 75 degree, this is also 75. So I am just writing TQP in place of TQP. I am writing TPQ. No problem because they are equal. Is equal to 180 degree. Take this theta here. So it becomes TPQ plus TPQ. 1 TPQ plus 1 TPQ will become equal to 2 TPQ. 2 angle TPQ is equal to 180 minus theta. I transferred theta here. Now take this 2 also here. So it becomes angle TPQ is equal to 180 minus theta divided by 2. Right? So it becomes angle TPQ that will be equal to 180 divided by 2 minus theta divided by 2. Right? This will get divided by both. So this becomes 90. So angle TPQ is equal to 90 minus theta divided by 2. This is equation number 1. Imagine this is equation number 1. Now, keep it as it is. Now look at angle OPT. Angle OPT, this big angle. It is the sum of two small angles, right? OPT is this is smaller plus this. They together become OPT. Right? Angle OPT is equal to 90 degree. Now question comes, why angle OPT is equal to 90 degree? Because angle between radius and tangent. OP is radius, TP is tangent. Theorem 4.1. Theorem 4.1. Radius and tangent at the point of contact are perpendicular to each other. Therefore theorem 4.1 says this. OPT is equal to 90 degree. But I can break OPT into two parts. How? I can write OPT as OPQ this plus QPT this. Right? OPT is from here till here, right? I am breaking it. I am writing it as this plus this. I can write. Right. So OPT can be written as OPQ, angle OPQ plus OPQ means this part plus this part. What is the name of this part? This part is TPQ, right? This part is TPQ. Right? I broke OPT into two parts. If you add them together, it will become OPT again. Will be equal to, or let me write here, one more step I can write here. I hope you can see OPQ plus TPQ is equal to this 90 as it is. Right? Angle OPQ plus TPQ is equal to 90 degrees. We have got this there. Because now we know that angle OPQ, we have to get this PTQ is equal to this. But angle TPQ is equal to this one. From equation number 1, angle TPQ is equal to 90 minus theta by 2. So I can write like this. This OPQ as it is plus TPQ. From equation number 1, I can write TPQ as 90 minus theta by 2. I replace TPQ by 90 minus theta by 2 will be equal to this 90 again. Right? This OPQ as it is plus TPQ from equation number 1. TPQ can be written as this because TPQ is equal to 90 minus. So I in place of TPQ I am writing 90 minus theta by 2. Where did I get this from? From 1. Now take this here. It becomes angle OPQ is equal to this 90 as it is. This 90 as it is. If I transfer this here, this plus 90 will become minus 90 there, and minus theta by 2 will become plus theta by 2. So it becomes minus 90, this plus 90 became minus 90, and minus theta by 2 will become plus theta by 2 on transferring to RHS, right? Now here, these two will get cancelled. So it becomes angle OPQ is equal to theta by 2. But what is theta? Theta is the angle PTQ in the beginning we considered. So OPQ is equal to, I can write theta as angle PTQ. Angle PTQ divided by 2. Take this 2 here. It becomes 2 angle OPQ. 2 angle OPQ is equal to angle PTQ. This is what we had to prove. See? We have to prove angle PTQ is equal to 2 times angle OPQ. 2 times. Therefore, I can write it like this. Angle PTQ is equal to 2 times angle OPQ. These two are the same, right? These two steps are the same. I'm just writing in the other way. Alright? So we got the same. Hope you all understood the question. That is this problem. And then we first took this triangle and we got this equation, equation number 1. After getting, we broke this complete angle into 2 parts and wrote 90, and we just did some maths here and we got the answer. Practice this theorem, this question well. It may come in exam, right? Hope you all understood. Don't forget to subscribe our channel and share it with your friends. Thank you.